going to be showing you some examples of RACF configuration, picking up where we left off in the previous video, getting started with RACF enablement. I'll be covering a handful of common good practices that were recommended by our leading internal RACF expert. Now, I have to point out that before configuring RACF, you must know your protection and audit requirements. And because these vary with environment to environment, take what you see here as suggestions, because some may be unnecessary for you, and you will absolutely need additional modifications. Also, I will not be covering auditing in this video, but we will likely devote a future video to RACF auditing. So in the last video, we left off at having run the RPIDIRCT utility, which gave us a file on our A disk full of RACF commands that, when run, will create our RACF database. A reminder, we have not yet IPL'd with our RACF-enabled CPLOAD module. So let's log back onto 7VM RAC 30. And this is the file we'll be changing, RPI SYSUT1. So I'll give a very brief reminder of the philosophy of RACF. So RACF protects resources and stores information about users, groups, and resources in profiles. And that's all it boils down to. To get a more in-depth explanation and understanding, you should read Chapter 1 of RACF Server Security Administrator's Guide, which is linked below. So our goal is to have a lean RACF database that protects only what users use and own. And it's easiest to do this before a RACF database has been created by changing this file. However, you can always make changes dynamically later on. So first, we're going to create a backup. SYSUT1 back. So the first rule we're going to implement is every human user ID will have a passphrase, but not a password. In RACF, these are two separate things. Passwords cannot be longer than 8 characters, while passphrases can have up to 100 by default. So on this demo system, there exist 2 human user IDs, Bill B and Karen T. And we'll call them our security admins. Here, the add user statements creates the RACF profile. And all we need to do to have these profiles be created with a passphrase and not a password is change this password parameter to phrase. So do that for both users and add single quotes to the inside parameter. We'd also like the minimum character length of passphrases to be 15 characters. We'll be implementing that later on, but to start, we need to lengthen Bill B's and Karen T's passphrases. And we'll do that by appending the 7-character string A, B, C, D, E, F, G to both. And this way, we avoid giving the same passphrase to both users. Our next rule is all non-human, non-no-log user IDs should be logon by. So on this system, that would be like operator, maint730, and maint. Whichever user IDs were already logon by in the directory will have a corresponding surrogate profile generated by RPIDIRCT. Here's operators, for example. So if your directory is already set up properly with logon by users, then you shouldn't need to do anything extra. Next, we will not be using the VM reader RACF class. If you don't want users interacting with spool files, it's more simple to restrict access to the CP spool, tag, and change commands. I won't be showing you how to do this, but one way is to create a new priv class and assign those commands to that priv class. So RPIDIRCT creates a VM reader profile for every user ID. So instead of manually deleting all of them, we will remove them with a pipe. And that pipe will look like this. Input our file. Filter out every record that has the VM reader keyword and write it back out to our file. And just like VM Reader, RPIDirect also creates a VM batch profile for every user ID. However, these aren't really needed because RACF is already smart enough to allow users that have logon by access to another user ID to send it commands. Because if needed, he or she could just log on to that user ID and issue those commands manually. So we'll use the same pipe, but change VM Reader to VM Batch. However, there is one user ID that requires a VM Batch profile, and that's FTP serve. So we'll go back into the RPIDirect file to manually add it. We'll be appending 3 lines. And to save time, I'm not going to type them out. I will paste them. The first line, the setrops command, allows me to create a generic batch profile, which I do in the second line. And any resource profile with an asterisk is generic, but 2 asterisks means all user profiles. So what we're doing here is giving FTP serve the ability to send commands to all user IDs, which for FTP is needed. Next, we're going to enable passphrase encryption, which we do with, let's see, this command right here. And now I'm putting it towards the top, so the encryption happens before the users are created. And lastly, we want to stop RACF authorization checking for classes we aren't using, in this case, VM Reader. So to do that, I'll be appending 4 more lines. The first line, put a little comment here to separate them, activates the VMX event class, which allows us to define a VMX event called noEvents and add both D and G priv class versions of the CP transfer and tag command, because we aren't using RACF to regulate interaction with the reader. Commands added to a VMX event with the /noctl append do not trigger RACF authorization checking. And the last line brings into effect our noEvents profile. And I actually need to add an L. There we go, I got cut off. Now we need to enable the use of passphrases and set the minimum length for all passphrases to 16 characters. So we are done with this file. This procedure is laid out in Chapter 6, section Modify Full Part Assemble and Text Files of ZVM-RACF Security Server System Programmer's Guide, which does involve us creating a RACF localmod and getting into the guts of RACF. So to do this, we need to log on to our service ID. So what we're going to do now is include the part ICHPWX11 as a localmod into the build for RACFVM loadlib. And how to do this is laid out in ZVM-RACF Programmer's Guide, Appendix D, section Modify Full Part Assemble and Text Files. So first, we need to get our vmsays RACF disks. And we need to copy ICHPWX11 text to the RACF localmod disk, the 2Charlie2 at filemode E. So let's find that file. There's 2 instances of them here. They're the same. So we will copy it to the E disk. And we aren't going to make any changes to it. So we can make it directly into a localmod with this command. Notice we're doing the assemble first and specifying L1 because this is our first RACF localmod. And we need to create a second localmod for the text deck and change this to 2. You can think of the assemble file as the source and the text deck as the compiled version. They both need localmods, and we need one more So we'll issue localmod RACF RPIBLLPA EXEC, which is the build list. Hit 1 to continue. Go to the bottom, and we're going to uncomment these last 4 fields here. So our ICHPWX11 part gets built into the CPLOAD module. File that. And now we need to rebuild RACF to pick up our LOCALMOD changes. So we'll do service RACF build. And put to prod to generate the new CPLOAD. And the last thing we need to do for passphrases is copy the sample file IRRPHREX sample to RACFVMs and RACMAINT-VMs 191 disks as well with the exec file type. Let's get those disks. We'll access RACMAINTs at filemode I and RACFVMs as Z. So let's find this file. Copy this at I. Oops, but I need to make it with the exec file type. And to set the minimum passphrase character length, we look for the variable phr midlen. So we'll just set both of these to 15. This statement sets it differently depending on if your passphrases are encrypted. Ours will be, but we'll set both anyway. And that's it. So we'll copy this to the other 191 disk. Okay. So now we can get rid of RACMAINTs and RACFVMs 191s. So next we need to configure the DIRMAINT-RACF connector. If you don't use DIRMAINT, then you would skip this step. This process is laid out in Step 5, Chapter 3, Tailoring the DIRMAINT Service Machine in book DIRMAINT Maintenance Facility Tailoring and Administration Guide. So first we need 7VM dir 30s 2 Charlie 2 and DIRMAINTs 11 Fox. Access 2 Charlie 2 at H and the 11 Fox as Z. So IBM provides the sample file config.rc samp dvh, which contains all the RACF options DIRMAINT has to offer. So we're going to copy it to the 11 Fox with the data dvh file type, and that will override RACF specific configuration entries. Okay, so we'll copy this to that 11 Fox with the data dvh file type. We can get rid of that H disk. We're going to change 2 lines here. Go down to RACF R define. Okay, so here in this section, you define the default resource profiles that are created for new users when you create users via DIRMAINT. So since we don't want users having VM reader and VM batch profiles, if we make their corresponding fields here blank, DIRMAINT will not create them. So here's the line for VM batch. We're just going to clear this out. And the same thing for VM reader. And that's it. So now we are ready to IPL with RACF. So we'll do cp shutdown REIPL module CPLOAD. So my system comes up auto warm start, but if yours doesn't, you can specify no auto. So autolog1 does not come up and start xautologging things, because you'll get messages like this complaining that the external security manager is not available. And so that's all that means, because we haven't initialized our RACF database yet. So what we need to do is xautolog RACMAINT, which is the backup ID to the RACFVM user ID. And this will allow us to log on to another user, which is called IBM user, to initialize our database. So IBM user is a prepackaged user ID that has the authority to issue any RACF function we need to initialize the RACF database. And the password is sys1, SYS1. And it's going to prompt you to change the password. We are going to revoke this user ID, so it won't be able to be logged on anymore. So after we're done using it, so what you change the password to is pretty irrelevant. So now it's time to run RPI builds, which will initialize the RACF database by issuing all those RACF commands in that RPIDIRCT file we were editing earlier. So we need 3 disks, 29 easy at D, 305 at C, and the 192 at B. And we'll issue cpterm more 00 because this produces a lot of console output. And we just issue RPI builds. And what we're seeing here is each command in that file being executed. If any command gives a non-zero return code, that command is put on your A disk in a file called RPI builds output. You can see any commands that didn't finish as they should have and reissue them. So we're seeing that this command was put in here, not sure why. So we'll just try issuing it manually and see what happens. And it looks okay. All right. So our database, our RACF database is now initialized. And so that means next we need to define the security administrator to RACF. IBM provides you with a default that is called sysadmin, but it is recommended that you create your own. For the demo, however, I will stick with sysadmin. The security admin user ID needs to have the special attribute to be able to execute all RACF commands. Okay, but first we're going to do a set pf12 retrieve to save some future typing. So to grant that special attribute, we'll issue RAC ALTUSER sysadmin special. And if you're using DIRMAINT, the DIRMAINT user ID also needs special to allow it to issue RACF commands when it creates user IDs. And so we'll issue RAC ALTUSER DIRMAINT special. And next we need to give operations authority to the service ID and 5 others in order to be able to build and install service. We could have put all these in the RPIDIRCT file to be executed by RPI builds, but the RACF program directory does list these steps, so we are following them. So issue RAC ALTUSER main 730 operations. And we're going to issue this again for BLDSEG, BLDRACF, BLDNUC, BLDCMS, and MIGMAINT. And again, these are all just users that are involved with service pretty much, so you're never going to be logging onto them, except for maybe MIGMAINT. So now we need to activate the VM MDisk, VM segment, and surrogate classes. We do that with RAC, set our ops, class act VM mdisk. And we do that for VM segment and surrogate. Surrogate handles logon by the way, in case that was not clear. So now it's time to log on to our security admin user ID, which in my case is going to be sysadmin. So I can log off of here and log on to sysadmin, which is by IBM VM1. I have to reset the password. Okay, so now that we have our security admin user ID, we no longer need IBM user. It's really just a security liability at this point. So therefore you should revoke access to it, meaning it can no longer be logged onto. So to do that, we'll issue RAC ALTUSER IBM user revoke. We'll also strip it of its operations and special privileges with RAC ALTUSER IBM user no operations and no special. So next, if you need to create any additional local mods, now is a good time to do it. A common local mod made is for part HCPRWA, because this is where you define behavior around security checks for different resources, such as mini-disk access. The default HCPRWA most likely will fall short of your security requirements, because for many situations, it tells RACF to defer to CP when a security check fails. So it'll ask CP instead of just failing the command, which is not ideal. So IBM does provide another version of this file, which is called HCPRWAC, which is the common criteria version, having more strict settings that are more appropriate for modern environments, making all those defers to fails. So we're going to create an HCPRWA local mod to update it with the HCPRWA values. And to do that, we will need to log on to our service ID. And we're going to pretend we are Bill B here. Copy and paste his password. Now I'll need to reset it. Paste. Okay. And because our autolog1 never ran, we need to xautolog a couple file pools. So like the service file pool. Oops. VM servu. Yes, that should be good enough. Okay, so once again, we need to grab our VMSES RACF disks. And we need to find our HCP RWC file. Look in here. This sysec is what we are copying. So notice all these fails here. Okay, so now we will be creating the local mods. So I'll do localmod RACF HCPRWA RPI base 0. This is the command needed to create a local mod for this part. A1. So notice all the defers here. Now there are fails. So you can read what these parameters actually are in the RACF Security Server Macros and Interfaces book in section sysec macro. For example, this disk F equals fail means that when a user fails an access check for a disk, RACF will fail the command and it will not defer to CP. You may need to make further changes to accommodate your security requirements. So we'll file this. And to pick up the changes, we do need to rebuild RACF and issue put to prod, but I will not be showing that. So we are finished with our configuration. Now we can bring up the primary RACF server, RACFVM, and we'll do that from operator. So once again, we need to impersonate Bill B here and log on with our new password. And so we'll force RACMate and xautolog RACFVM. So now our RACF production server is up and running. One last change you'll need to make that I won't be demonstrating is to the profile execs of user IDs Autolog1 and Autolog2. Autolog1 should only xautolog RACFVM, which will automatically xautolog Autolog2. So you should move everything that you were xautologging and doing in your profile exec of Autolog1 to that of Autolog2. So this is the end of our preliminary configuration. You will need additional measures to cover your security requirements, as well as auditing requirements. This was really just meant to get you familiar with the RACF configuration process and to have an idea of what to expect when you go to set up your RACF environment. I heavily recommend reading the ZVM RACF Security Server Security Administrator's Guide to better understand RACF and what you'll be doing. You can read about auditing in ZVM RACF Security Servers Auditor's Guide. Thanks for watching.